Now third part in the integration we are having, that is integration by parts method. So by parts means whenever you have multiplication of two functions, that is u into v, and we have to integrate with respect to x, then keep first function as it is, integrate second function, minus integration of integrated term and derivative of that first function u, then integrate with respect to x. So we have here one example, that is integrate x into sin x. So here we can't use substitution method, because if you substitute here sin x, you're gonna get differentiation as cos x, so which is not the correct way to integrate this. So if you substitute x, its derivative you'll get it as 1, so you won't get any substitution here. So we are not using substitution method here. So we are first denoting here integration of x into sin x dx. So as we have denoted this function u and this as v, we will apply this rule, u into v rule. So here by parts method, first function you are keeping as it is, that is x, you are keeping as it is. Now you are integrating second function, that is sin x dx, that is v, minus integration of, you are keeping that integration as it is, one more integration. So whatever this part is there, sin x dx, same you are taking here, that is integration of sin x dx. So I'll put here bracket, so there will be no any confusion. And next it is d by dx of u, that means differentiation of this function, that is d by dx of x and dx you will get. Okay, now as you know, integration of sin x, it is going to be minus of cos x, so put it in the bracket, minus integration of, now integration of this function, it is going to be minus of cos x, right? And derivative of x with respect to x, it is going to be 1, and that dx, right? Now further we can simplify this, x into minus cos x is minus x into cos x, minus, and this minus it will become plus, integration of cos x into 1, it is going to be cos x dx. So now you can integrate this function, because you have to continue this process until you get the term free from integral sign. So here we have here minus x cos x plus integration of cos x, it is going to be plus sin x plus c. So here whatever this final answer you have got is the required answer of your question. Hope you are understanding this. So here whenever u into v is there, you need to remember this formula, and same formula you have to apply here. So this is nothing but, here it is u, this is v, this is v, this is u. Now similarly we are having one more function in terms of cos x. Previous problem was x into sin x, but this problem is x into cos x. Same way, first denote this as u, this as v, apply u into v rule and try to get its answer. So answer for this question is going to be x into sin x plus cos x plus c. Please verify your answer with this answer. Now next problem we are having as integration of x square into e raised to x dx. So first I'll denote this as I is equals to integration of x square e raised to x dx. Denote this as equation 1. So denote u as x square and v as e raised to x. So I can apply that formula, that is u into v, which is equals to u integration of v dx minus integration of integrated part v dx into d by dx of u and dx. Okay, so according to this formula we will follow as I is equals to integration of, that is u function as it is, that means x square you are keeping as it is. Now integration of next function, that is e raised to x dx minus integration of integration e raised to x, because v is there, so e raised to x will get dx and d by dx of u, that is going to be x square dx, right? So here x square we are keeping as it is, integration of e raised to x, it is going to be e raised to x minus integration of, here integration of e raised to x is e raised to x for this part, integration of e raised to x, it is going to be e raised to x, and derivative of x square, it is going to be 2x dx. Now if you observe here, this term we will keep as it is, minus, if you observe 2 is constant, take it outside integration, this x term I will take as first function now, and e raised to x dx. So if you observe, again x into e raised to x is there, that means again we have to use u into v rule for this particular function. So again we will apply that rule. So here x square e raised to x, I'll keep it as it is, minus, to keep it outside, now u, apply the same rule again, that means first function you are keeping as it is, that means x you are keeping as it is, integration of e raised to x dx, minus integration of integration e raised to x dx, and d by dx of x you are writing, so it is with respect to x, right? So these two terms we are keeping as it is, minus 2 times x, integration of e raised to x is going to be e raised to x, minus this first integral sign I'll keep as it is. Now integration of this part, it is going to be e raised to x, and derivative of x is going to be 1 dx. Same time I'll rewrite again 2 times, it is x into e raised to x, I'll keep as it is, minus integration of e raised to x, it is gonna be e raised to x, because e raised to x into 1 is e raised to x only, and integration of e raised to x, it is gonna be e raised to x plus c. Now if you observe, this term is free from integral sign. Now you can just multiply this 2 throughout, and you can take e raised to x outside. So it is x square e raised to x minus 2x e raised to x, minus minus, it is going to be plus 2 e raised to x plus c. Now from these terms, 3 terms, 1 2 3, you can take e raised to x outside. So we have here e raised to x inside bracket, x square minus 2x plus 2, and here we have plus c, which is the required answer. If you want to further simplify, you can simplify this bracket by factorizing it, or else keep it as it is, which is the required answer. Now last example on by parts method we are having is integration of 2x plus 3 into sine 2x dx. So here again we are denoting this 2x plus 3 as u and sine x as sine 2x as v. So again we are following that same formula. So we have here first function as it is, that is u as it is, integration of v, that is sine 2x dx, minus integration of integrated part, that is sine 2x dx, and derivative of 2x plus 3. Now this term we are keeping as it is. We know the integration of sine x, it is minus cos x, but here x is in terms of 2x. Okay, so here you will get cos 2x, and coefficient of x is, if you observe, it is 2, so that 2 we are dividing here, minus, similarly integration of this part is going to be minus of cos 2x upon 2, and derivative of this 2x, it is going to be 2, and 3 it is going to be 0, so obviously we will gonna get here 2 only. So this 2 and this 2 get cancelled, so we are remaining here with only minus minus plus integration of cos 2x dx, and here in this side 2x plus 3 into minus of cos 2x, it is going to be minus of 2x plus 3 cos 2x and upon 2 plus this term. Now again integral sign is there, you need to integrate, so only one term is there, so directly you can integrate. So this term I am keeping as it is, integration of this is gonna be sine 2x, but coefficient of x is here 2, so again divide it by 2 plus constant of integration, so which is the required answer.